Hi there, my name is Kieran Kavanagh, and I'm a Principal Solutions Architect at Amazon Web Services. I specialize in artificial intelligence and machine learning, and I work on the Amazon.com account. So I get to work with teams all across Amazon who are using AI ML at scale for all kinds of use cases. And that's exactly what we're going to talk about today. We're going to cover some example AI ML use cases at Amazon, and we'll also talk about some of the lessons learned from Amazon's use of AI ML at scale over the past decade and a half. I'd just like to start by level setting the conversation about one of the reasons why AIML is important to Amazon. Amazon's mission is to be Earth's most customer centric company. So it stands to reason that the customer experience is a really important part of Amazon's overall business model. AIML can be used to enhance customer experience in many ways. And in the coming slides, we'll talk about how Amazon is using AIML for that purpose. I'd like to start with Prime One Day as an example. This is a service whereby you can order certain products on Amazon, and if they're eligible for Prime One Day, you can have them delivered the very next day. Now, I remember when this first launched, I was amazed that I could order something online and it would show up the very next day. And now we're even seeing same day deliveries happening. So in this presentation, we'll show some of the magic behind the scenes that Amazon is using to make all of this work for millions of customers every day. And spoiler alert, it's not actually magic, it's machine learning, but sometimes it's difficult to tell the difference. What you see here is a conceptual overview of Amazon's supply chain. Now, in the real world, the supply chain is vast and complex. For example, Amazon handles billions of packages in 150 different countries around the world. And people's buying behavior can sometimes get pretty intense. If we take Prime Day for an example, in Prime Day 2019, Amazon handled more than 175 million customer orders in the space of 2.5 days. And that equates to almost 3,000 orders every minute during that time. So how do they make all of this happen then? Well, one of the first important steps that we see here is forecasting. Amazon needs to be able to determine what kinds of products they should procure and also where they should store those products in their fulfillment centers. So factors like capacity in the fulfillment centers come into play in this regard, and also where they should be placed in terms of having products as close as possible to the customers that are likely to want to purchase those products. And these kinds of decisions change based on region and based on the time of year and lots of other factors. Finally, there's the fulfillment process, whereby Amazon needs to keep track of all of the packages while they're being delivered to customers. Now let's take a look at forecasting in a bit more detail. There are some products on Amazon.com that are relatively easy to forecast. If we look at things like household cleaning products, people generally tend to use them at the same kind of rate throughout the year. So you can use standard statistical modeling to forecast some of these types of things. Also, even things that are seasonal in nature, like sunglasses and sun hats, it's pretty easy to determine that people are more likely to purchase these things in summer than at other times of the year. However, there are some types of products that are not so easy to forecast. If we think about new products that are coming onto the market that weren't there before, or you have highly specialized products, or maybe there's recently been a new superhero movie that hit the screens and has been really popular, and suddenly all the kids are asking their parents to purchase superhero costumes for them. For these types of things, you need to be able to quickly identify those unique patterns and react accordingly. And this is where machine learning can help. When we say Amazon is using machine learning, let's take a look at what we mean in more detail. So about a decade and a half ago, when Amazon started using machine learning at scale in production, they started with algorithms such as decision trees. With a decision tree model, what your model does is it goes through a sequence of steps until it reaches what it believes is the best decision for the given use case. And this works really well for lots of use cases even today. However, as Amazon's forecasting needs became more complex, as their infrastructure became more complex, as they started to have more products on their websites, and as they started to have more people purchasing those products, they needed more complex models for this forecasting process. And so nowadays, what you'll see being used are neural networks. Neural networks were originally conceived based on how the human brain is structured, whereby you have all of these different neurons communicating with each other in lots of different ways to create very, very complex decision patterns. And similarly, with artificial neural networks, they support much more complex decision processes than could be supported with earlier models such as decision trees. And also, you can use much more complex combinations of data as inputs to these decision processes. So when Amazon is forecasting more than 400 million items every day, it needs pretty complex models. And what you'll see is a mixture of different types of models being used, different types of neural network architectures, depending on the specific use case. But that's enough theory for now. Let's get back to the real world and see how Amazon is using this to improve the customer experience. We talked about the fulfillment centers being a pretty important part in the overall supply chain. So let's take a tour inside one of these fulfillment centers and see what's going on in there. Just to set some context here, an average fulfillment center facility can ship about maybe 700 units per minute. And you also have the same number of units coming into the facilities at around that same rate for replenishment. So products are coming in and out of these facilities and moving around within the facilities at a very fast rate. This is why you'll see these mobile shelving units here that are designed to optimize that process as much as possible. One of the first things you'll notice is that products are stored randomly on the shelves. And this may seem counterintuitive, but Amazon realized that this is actually much more efficient than having dedicated locations for specific item types. And that's for a couple of reasons. One of them being you can use machine learning to optimize the storage space required by determining which products should be stored next to which other products based on their dimensions, fitting them together like a puzzle. And another reason is to optimize how quickly you can fulfill orders. For example, if you have a customer that orders two different items in the same order, you don't want to have to get one of those items from one corner of the warehouse and another one from the very opposite far corner of the warehouse. That would not be very efficient. So when items are coming into the warehouses, machine learning is used to determine where they will be stored. And also similarly, when items are being picked out to fulfill an order, as you can see the person in this graphic doing, it would be very inefficient if every time one of these mobile shelving units came up to the person's workstation that they had to look through all of the shelves to find the items that they need. So similarly, machine learning is used to highlight each of the shelves that contains the item that the person needs for the order that they're currently working on. And this is an AI/ML session, so it would not be very nice if I didn't talk some more about those robots that you see there. Those robots, the routes that they take throughout the fulfillment centers, of course, all of those routes are optimized by machine learning. And also bear in mind that there are lots of these things running around the place. So you want to make sure that they don't run into each other. And you would not be able to do all of that without AI/ML. There's simply no if then else set of statements that could capture all the randomness of how these things need to move around the warehouses every day, depending on what people are ordering. And a fun fact about those robots, they can lift more than 1,000 pounds in weight and travel at about 5 miles an hour. So they could lift a grand piano and do about 30 laps around a soccer pitch in an hour. Don't try that at home. Now let's take it out of the fulfillment centers and let's follow the packages to the customer's doorstep. First of all, the routes that the packages will take to the customer's doorsteps will be optimized via machine learning. And another thing that's optimized via machine learning in that process is packaging. Now, why does this matter? Well, considering that Amazon delivers more than 10 billion items a year, this matters a lot, and for a number of reasons. One is around reducing waste. Sustainability is a very important priority for Amazon, and they do a lot of work in this space, such as pioneering things like the climate pledge, for example. Another reason is tying it back to the customer experience. I know that when I receive packages from Amazon, I much prefer to receive, wherever possible, those smaller, lightweight packages that are easier to open and easier to dispose of, rather than larger boxes that sometimes take a bit more work to open them up, and also then you need to break them down afterwards for recycling, etc. And the third reason is simply shipping efficiency. Smaller packages take up less space in shipping containers. They take up less space in trucks and vans, and therefore you need fewer trucks and vans on the roads to deliver them. Let's take a look in a little bit more detail about how packaging is chosen. Before machine learning, this was a manual task. Basically, people in the fulfillment centers, depending on whatever items they're picking, would decide what kind of box to use to pack those items in. Now, if they choose a box that's too small, then they'll need to go and get another box and not waste time. And if they choose a box that's too big, then that wastes packaging materials. Over time, Amazon built machine learning models to use all of the data they had about the products in their catalog to much more accurately and much more precisely determine what kind of packaging could be used. And so, of course, it uses things like the dimensions of the items that are going to be packed, but it also takes more complex things into account, such as the fragility of these items. Items that are prone to damage or prone to leakage, they will get extra protective packaging, whereas other items that are not so prone to damage do not need the same kind of packaging. And Amazon's models have become so sophisticated in this regard that they can take even much more nuanced details into account. If we take Lego products as an example, many Lego products are toys for kids and they're not fragile and they can be shipped in regular packaging. However, some Lego products are collectible items. So if you look at the Star Wars kind of collector's items that they provide, for example, and those kinds of things, people want to receive them whereby even the packaging that they come in, the original packaging that they come in, is completely pristine. So those kinds of things require extra protective packaging. And the models are able to discern at that level whereby even if they see two Lego products that need to be packed, they have similar dimensions, similar weight, made from the similar kind of materials. However, it can determine that one of them is a collector's item, whereas the other one is a regular child's toy, and they will get different packaging accordingly. Now, what does all of this mean for Amazon's business and for the environment? Well, here you can see over the past few years how the number of boxes being used has reduced and the number of mailers has been increased instead. And also you can see this concept of zero Amazon packaging. Often Amazon's machine learning models are able to determine that the packaging that is used from the original manufacturer is safe enough to transport the item sufficiently to the end user, and therefore no additional packaging is required. And to put some more figures around this, last year, Amazon's models identified more than 125 million customer deliveries whereby mailers could be used instead of boxes. And this helped to prevent more than 9,000 tons of waste. Just to put that in some more perspective for you, have you ever been to Paris in France? Well, 9,000 tons is almost how much the Eiffel Tower weighs. And to wrap up this section then on the use cases, we talked about supply chain automation and optimizing packaging, but there are lots of other use cases and businesses across Amazon that use AI/ML at scale. If we look at Prime Video as an example, when you log into Prime Video and you see recommendations for content that you might enjoy, this is machine learning at work. Also, Amazon has something called Style Snap, where you can take photographs of items of clothing in the real world, and then you can use those photographs to search for similar kinds of items on Amazon.com. And another interesting use case are the Amazon Go stores. If any of you have had the opportunity to visit a Go store, it's a really unique and novel experience. Basically, you can go in, take whatever you want, and just walk right out the door without security running after you. So it's a very, very novel and very convenient experience. And there are lots of other use cases also, such as Alexa and many others that we don't have enough time to cover in today's discussion. What I do want to talk about next are the lessons that have been learned from Amazon's implementation of these AI/ML use cases over the years. Let's start with some generic data from the industry. This is from a Gartner survey that was performed, where companies talked about the most common challenges they've run into with AI ML adoption. Now, I'm sure many of you will not be surprised to see that having the required level of skills on your staff and in your organization is important for being successful in AI ML adoption. And that can be difficult sometimes because AI ML are complex concepts and they are complex realms, and it can be difficult to train people up on these complex concepts. I will share some resources with you later that will help you with that. Also, what you're seeing here is that even if you do have the required skills and you have some really great ideas, there's generally some other challenges that you're likely to run into when trying to implement AI ML projects. So how has Amazon addressed many of these challenges? Well, there are 5 main patterns that have emerged that are important to focus on. And we'll go into these in detail in the coming slides, but just at a high level to summarize them here. First of all, if you're serious about implementing AI ML projects, then you need to ensure that you're establishing an ML first culture in your organization. We'll talk some more about how to do that. But basically, what you want to do is you want to make sure your teams are aligned on ML as a priority. Now, when your teams are aligned, you then need to make sure that you enable them for success, that you give them everything that they need and set them up in a way that will make it easier for them to work on AI ML projects. And then in the center here, you can see data, because data is the heart of machine learning. So we'll talk about that in some more detail also. And when you have all of these things set up, one of the next important things you do is deciding what is the first project that you should work on as an AI ML implementation. And then how do you scale out beyond that? Looking at the first one in a bit more detail, how do you start to establish an ML first mindset and culture in your organization? Well, many companies have annual or quarterly planning processes whereby your teams plan out what they're doing over the next few months or what they're going to work on. Leaders at Amazon started to introduce a simple question into this process. They began to ask their teams simply, how are you going to use machine learning? And saying we won't is not an acceptable answer. Basically, what this does is it encourages your teams to start thinking about how they may be able to use AI ML in their use cases. And I can almost guarantee you that if you don't start actively asking this question, they probably won't start thinking about it because most likely they have their own deadlines that they're working on, they have their own use cases that they're working on, and they may not have time to step back and think about, hey, is AI ML something that we can possibly use here? However, you will be surprised when you do start brainstorming how broadly applicable AI ML is. One mechanism that we've seen to be quite successful in this area is hackathons, whereby if you encourage your teams to start working on something together, maybe brainstorming some new ideas and building a prototype, this can be a fun experience for them. And then also some of those things may end up being things that you actually bring to production later. Also, once your teams are thinking about ML as a priority, you need to make sure that they're set up in a way that will help them to work effectively on AI ML projects. An important thing here is to ensure that you're bringing together lots of different people from different types of backgrounds, different types of expertise, especially merging your business people with your technical people so that they work very closely together. For example, you may have new requirements and new theories coming in from your research scientists and your product managers. You want to make sure that they can quickly talk to a data scientist and data engineer about what kind of data may be available to support this new initiative. You also want to make sure that you're very quickly getting feedback from your ML platform engineers about how quickly could you take this new thing to production. And similarly, you want to ensure that they have all the tools they need to work effectively on AI ML projects. Now here I'm showing the AWS AI ML service stack. What we're showing here is that there are lots of different services that you can use for AI ML purposes. In the AI ML service stack, what you see at the top are pre-built services that cater for common AI ML use cases in the industry, such as natural language understanding, image recognition, forecasting, personalization, and much more. And basically, whenever you find a service that does what it is that you need to do, it makes a lot more sense to simply use that service rather than building and maintaining something yourself from scratch, which can take a lot more time and effort and more expense. However, sometimes your data scientists do need to build their own models. Sometimes your teams need to build their own machine learning tooling from scratch. These are usually for more proprietary use cases or where your teams already have a lot of AI ML experience. And for these, you can see platforms such as SageMaker, for example. This can be used for all of the steps in the process from data preparation to training models, deploying them in production, and monitoring them afterwards. And also at the lower tiers here, you can see open source frameworks and also GPUs and CPUs that people need to use for AI/ML services. And so if your team needs to build something from scratch, then you need to make sure that they have the right tools that they can use for the job. And this is true at Amazon also. There's no mandate for Amazon teams to use any specific service. If they need to build something themselves from scratch, then they're absolutely welcome to do so, as long as that's the best thing for their business case. Now let's talk about data. Machine learning algorithms learn from data, so it's a really important part of the overall process. And Amazon realized that many of their teams that were working on AI/ML projects were spending more than half of their time, or in some cases, a lot more than that, even just trying to find and prepare the data they need in order to start training machine learning models. So they spend all of this time preparing data before they can even start trying to train any models. So when Amazon modernized its data lake on AWS a few years ago, there were a few things that they set out to get right from the beginning. First of all, they realized that teams that work closest to your customers are the ones who are best positioned to innovate on behalf of those customers. So they need access to the data they need as quickly as possible. And when they get access to that data, they need to be able to bring it into whatever tools they like to use for their own purposes. And all of this should happen in a self-service manner. They should not need to go through some other team to get the data they need. So this is about breaking down data silos in your company. So basically, what you want to establish is this kind of data marketplace where teams can search for and find data that they need to use, much like Amazon.com customers can come along to Amazon.com and search for products that they want. Now, when you have all of this set up, you have your teams aligned on the right priorities, they have the tools they need for AI/ML use cases, and you have access to a data lake. The next thing you need to do is think about, okay, what will be a useful thing to choose as an ML project? And Amazon realized there's a number of things that are important in this decision. First of all, you want to ensure that whatever you choose is going to address a real business problem. As much as machine learning is fun, you want to choose something that will either address a current business problem or will introduce a new solution that will differentiate the business in some way. And here in the middle, again, we have data. At the beginning of an ML project, ensure that you have access to the data that you're going to need for that project. Because without this, your ML project could be a non-starter. Also, choose something that's likely to have some measurable level of success within the first half a year or so. And this may not be something that completely revolutionizes the company, but you want to have some measurable level of success in a relatively short time frame. Let's say, for example, you're going to improve customer engagement by 5% over the next 6 months. And the reason you want to choose something like this, where you can have a very specific goal, is that it helps to show that you can implement an AI/ML project for a specific goal and achieve that goal to some extent. And this helps to build confidence in your organization that they can do this. It also helps to get the sustained attention and support you need from your stakeholders in order to be able to scale out further beyond this. And in terms of scaling out further, another data point I'd like to share with you from another Gartner survey that was performed is that CIOs who responded to the survey said that their companies expect to double the number of AI projects that they're working on over the next year, but they expect less than half of those to actually make it to production. And this highlights a very common challenge that companies often run into when working on AI/ML projects. It's all really great when people are having fun in the labs and they're coming up with cool ideas and building cool things. But taking something that's a cool idea in the lab to something that operates at production scale on an enterprise-wide level is a whole different challenge altogether. And you're likely to run into a number of challenges along that journey. And we've talked about some of those already and how Amazon addresses them, such as ensuring teams are aligned on the right priorities, breaking down silos, making sure you have very clearly defined business outcomes defined before you go into your ML project. Also, there will be some things that are specific to your ML implementation. And also, you may have some very specific governance, compliance, and security requirements. So you need to identify and address these as early as possible. And then finally, when it comes to scaling something out to production, what you really want to do is ensure that you have a pipeline in place, an end-to-end pipeline that can automate all of the steps in the process as much as possible. So these are all of the steps required from data preparation to training your models, deploying those models in production, and monitoring them once they're in production. And bear in mind that this is usually an iterative process. Usually, even when your models are in production, as new data becomes available or new technologies emerge, you want to be updating those models on a periodic basis. So you want to make sure that anytime you need to update a model, all of those steps in the process required to do so are automated as much as possible. And to summarize then, we talked about how Amazon uses AI/ML at scale to improve customer experience across all operational areas. We talked about how they set up a system of enablers to enable this. And then we also talked about how it's really important to have an end-to-end process in place that automates as much of the steps as possible when you want to scale something out to production. Now, at this point, I'd like to share with you some additional resources that can help you to get more ideas about how you may be able to use AI/ML at your company, and also some resources about how you can learn more about machine learning itself and how you can help your employees to get trained up in these important concepts and set them up for success. And finally, I'd like to thank you for attending this session. I hope you found it interesting. Please do complete the survey as I'd love to hear your feedback, and I hope you have a wonderful rest of your day. Okay, that's it, guys.